Hello everyone. Next unsolved question we have in our BFS playlist is find largest value in each tree row. Let's go to the question. So given the root of binary tree, return an array of the largest value in each row of the tree, zero index tree. Okay, so a pretty straightforward question. If you know, like we can do it as it is a tree, binary tree mainly. So we can do BFS or DFS. So if we go with BFS, we will do level order traversal kind of thing. Okay, so like 1, then we go for 3 and 2, then we will find the maximum. The question is to find the maximum in each row, such that in each level. For first, for 3 2, the answer is 3 2. It is trivial, so answer will be 1. For 5 3 and 9, the answer will be 9. So we can go for BFS also. When we try DFS, it will need an extra parameter like some level, or I will add level to it. Like we will define a function DFS. Okay, and we will take the root. Initially we will keep the level as 0, and then we will go for another DFS to root dot left. Okay, and root dot right, not like this, sorry. We will go for root dot left, and we will also add level plus 1, and for each level plus 1 we are gonna store the maximum and minimum in an array. Like for each level, level of, not level, this array of that level is equal to like max of current this, comma, the whatever we will get from this. Okay, we can do this, like it's no big deal. Let's try it with simple BFS. If we will have time, we will can do DFS too, but let's do it simply with, okay, let's do it with BFS. Yeah, BFS. So let's take a Q. Q is equal to root. So here we are gonna do BFS. So while Q, let's create like current level. Instead of writing this, we can say current level, or current level is Q now. Q is our current level because we are starting from here. So this is like next level. We have to fill our next level. So how we are going to fill the next level? We will check. We will keep taking the next level while Q is non-empty. Okay. So while Q is non-empty, if okay, while Q is not non-empty, pop the node Q dot pop from starting, as it is Q starting. If node dot left is there, node dot left, then next level, append next level dot append node dot left. Okay, we have to do same with, okay, let's do same with node dot right. Node dot right. Okay, yeah. So next level dot no, append node dot right. Now at this point Q will got empty. Now Q is empty. Now Q is empty. So what we will do, we will append Q. We will append, not we will update Q. Like now the Q will become our next level. Okay. And yeah, this will continue on until this while Q is properly vanished. Okay, like we traversed the whole array. Now the situation is we have to find the maximum of it now. So we already have a level. So our result max, the result max will be, initially it will be root dot left. let's check whether the number of nodes can be 0. So we have to check first. If not root, return 0. I mean return empty array. Okay. Else result dot max is equal to root dot val. Okay. And here update the max of it. Q is equal to next level. So for I in Q, okay, instead of this, just max dot append max of node dot val in next level for node in next level. Yeah, this will work. Node dot val, so rather we should keep it in the list. Yeah, max of node dot val for node in next level and return res max. Correct. Max. Let's see whether our code is running or not. Max. Okay, yeah. So if next level, then only try to do this. This one more condition we should put, because at the end of the leaf, max argument will throw an error that the list you are putting in is already empty. Okay. So this was our BFS solution. We have time to complete the DFS too. It's only 7 minutes. So let's go for DFS now. Okay. If not root return 0, it will be the same. So let's go for our DFS solution. DFS. So for DFS, I will always take a helper. It will a helper function. So initially we have root, and level for root is 0. Okay, and what we will do, max number of nodes are, let's check what are the max number of nodes. It is 10 to the power 4. Okay, so level can be 10 to the power 4. So let's create all the levels. Level array equals 0. For each level I will store the max. 0, we have to store the max or min? Largest, yeah, largest. And node val can be negative also. So instead of 0, we are gonna put float of minus infinity. Float of minus infinity. Okay, this is our level array. Now what we will do, we will do, yeah, if root. If not root, then okay, if not root, then return. Okay, and if it's not the case, then update level array of level equals max of root dot val, comma, my computer is working slow, I don't know why. Root dot val, comma, level of array. Yeah, we are gonna update our level array. Like here I should comment it out, like it contains max of each level. Okay, so yeah, now what we can do is float of minus infinity, no, into total number of possibilities are 10 to the power 4. Okay, let's take 10 to the power 4. Yes. So max of root dot well level array level. Now we are gonna call it on root dot left and root dot right also by increasing level from here. So it is DFS. You can see we are at first going till the till, uh, till the depth of left array, left tree. Then for right tree, it's going like this. That's why you can see, you can observe that it's DFS. So okay, we are going like this. Yeah, it will work. Now let's simply call our helper root. There's one more thing, that our level array should be of maximum height. So it will be update. We have to return the level array up to index where we find float of infinity. So it's like return level array uh, starting index to where we find first where array dot index of float of infinity, float of minus infinity rather, I should say. Yeah. Okay, let's try this. It's working also. Let's see. Yeah, it's working. So yeah, it's done. Thank you guys. Keep watching it. Subscribe also my YouTube channel.